In this next section, we're going to continue our operations with radicals and we're going to focus on multiplying radicals. And there's really about 3 different ways that we multiply radicals, okay? And by the way it's set up, you'll be able to tell which strategy you want to use. Now, when you multiply radicals, the idea, because a radical is really something to the 1/2 power. What happens is if I have 2 radicals that are being multiplied together, I can rewrite that as x to the 1/2 times y to the 1/2. Since they both have the same exponent, I can use my exponent properties to write the x and the y together. And even though these were different radicals, we can put them both under one radical, okay? So the rule is not the same when you add and subtract, all right? And so this is based on our exponent properties that we learned last week. So in general, I want you to remember the idea that when you multiply radicals, we can combine them in one radical, as long as they're the same type of radical, which they will be, all right? So since we're really multiplying under a radical, we still want to break down each radical, look for doubles, triples, whatever the radical value is, and then we're going to multiply all the outside numbers and all the inside numbers together to simplify once we're done. Okay? So let's look at example 1 and 2. This would be when that simple idea would be illustrated, the first scenario. So on example number 1, we've got root 20 times root 14. Now you have some choices. You can multiply 20 times 14 and get 280. But really, because we're going to break this down, there's no need to actually multiply the 20 and the 14. So I just leave them separate and I rewrite them under one radical. What we want to do is we want to break each of those 2 numbers down, remember everything's with multiplication, into its factors. So 20 I'm going to pick as 2 times 10, and 14 is 2 times 7. Now, you have a choice. At this point, I can take out the doubles, or I can just keep breaking down and take all the doubles at the end. It's really going to be a choice. I like to take my doubles out as soon as I can, just so I can focus on what's left. So a double 2 is going to come outside, and then I've got the radical, and I want to break down the 10. So 10 is 2 times 5, and I have the 7. Now, I've got 2, 5, and 7. They don't break down any further, and I don't have any doubles. So what do? Well, the rule says we multiply everything outside together and everything inside back together. So the 2 is the only number on the outside, and 2 times 5 times 7 is 70. So 2 root 70 is our final answer. Now, we could have done this problem a lot of different ways, but we'll all end up with the same answer. Let's look at example number 2. So on example number 2, we have 2 numbers outside and 2 numbers inside. So once again, we can think of the 3 and the 7 on the outside. You can multiply them together right now if you want. And I have the 12 and the 15. We can also multiply those together if you want also. And I do get a lot of students that do that. And it's not wrong, it's just an extra step. So I am going to multiply the 3 times 7 to give me 21. We need to break down 12 and 15. So 12 I'm just going to pick as 6 times 2, and 15 is 3 times 5. Okay? Well, I don't have any doubles, but I can break down the 6. Now, you can break it down here, because I can keep all my numbers pretty straight, or you can rewrite the whole problem. So I'm going to cross out the 6, and I'm going to write 2 times 3. So as long as you can see all the numbers that you want to look at, you can just break it down on each step. So I've got a double 2, which means a 2 is going to come out to multiply, and we have a double 3. So I'm also going to multiply by a 3. The 5 is the only single that's left. So now we're going to clean it all up. We're going to multiply all the outside numbers. So 3 times 2 times 21 is 126. And the only number inside is 5. Okay, so no matter what factors you chose or what strategy or how many steps it took you, we'll all end up with 126 root 5. Now, the second type of problem has us reviewing the distributive property from secondary 1. So this one you can tell looks different because we have a number outside a parenthesis and we have two terms inside a parenthesis, and that's how we know we're going to distribute. So I'm going to review what distribute means. So when we distribute, we take the term outside and we multiply by the first term. Because remember, a term is separated by a plus or minus. So 7 is our second term, and 4 root 11 is our third term. So we are going to multiply by each of those terms. So if I write this out, we've got 5 root 11 times 7. I use the sign between the two terms, and then I'm going to multiply the outside term times the second term. So 5 root 11 times 4 root 11. I've already accounted for the minus in my problem. And so that's distributing. So now we've taken one problem and we've kind of turned it into two of the problems that we just got done. So 11 doesn't break down. All of this is one term. Okay, when you multiply terms together, that's still just counted as one big group, and so we follow our rules. 11 doesn't break down, so I'm going to multiply the outside numbers together, and the inside number stays the same. Now, all of this is being multiplied, so that's all one term. And this we can think of as 5 times that 4, because it's outside, and then these 11s are both inside. So we can put them together. It's a square root, so we want doubles, and I happen to have a double. So what does that mean? That means we're going to have an 11 on the outside, and nothing's going to be left on the inside. So this term actually will not have a radical on it. So 35 root 11 minus, we've got 11 times 5 times 4 is 220. And I don't have anything left inside the radical, so it's just 220. One of our terms has a radical and one of our terms does not, so there's nothing we can do to simplify that answer. Let's try another one. So let's look at example number 4. Same thing, we've got one term outside, a second term 6 root 5 inside, plus a third term on the inside. So that's how we know we're going to distribute. So I'm going to multiply the first and second terms. So we've got 2 root 3 times 6 root 5 plus we're going to multiply 2 root 3 times the second term. And I'm just going to write it out for now. You can see how some of these problems can get pretty complicated if you're trying to do it all in your head or skip some steps, so I don't. All right, so now we need to simplify each of these two terms. All of this is together, and all of this is together. So the outside numbers can go together. We've got 2 times 6, which is 12. And I've got 3 times 5. Remember, I can multiply that, but I know I'm going to try to break it down and look for doubles. I'm choosing to leave it alone. Plus, same thing, I've got 2 and 7 on the outside. We can multiply those together, and I'm going to leave the 3 and the 3. Okay, so now we're still working on looking for doubles to simplify. 3 and 5 don't break down, And so what does that mean? Well, that means we can't simplify this, so I'm going to actually multiply them back together. 3 times 5 is 15, and I still have that 12 in front. On my second term, I have a double 3. So once again, that can come out and get multiplied. So 3 times 14 is 42. And I don't have anything left on the inside. So this term doesn't have a radical on it. So this would be our final answer. All right, there's a third type of problem that is definitely going to be the longest. So on this problem, you notice I've got 2 terms in the first set of parentheses and 2 terms in the second set. So I've got 1, 2, 3, 4 terms. And so we do what's called double distributing. Now, we're going to learn a better name or acronym for this in our next unit. So for now, I'm going to call it double distribution. And that's really what it's going to be called. We're just going to come up with an acronym later on in this class, okay? So the way double distributing works is I'm going to take the first term, and we still want to multiply that by both of the terms in the other group. So if I write this out, we've got 6 times 5, and then this has a minus, so I've got 6 times that second term, which is 4 root 7. Okay. Now, I'm done with the 6, and so that's just a single distribution. So the double distribution is when I take, remember, a minus and a negative. I need to consider those the same. So I'm going to take that second term in the first group, which is negative 2 root 7, and we're going to also distribute that. See why it's called double distribution. So we've got negative 2 root 7. I'm going to keep it back in black. Times the first term is 5. And then I've got negative 2 root 7 times the second term is negative 4 root 7. Okay. It's got old wide steps. Now, this does keep it a little hard to keep track of what you have, but we'll get used to it. So the first term are just 2 numbers. So 6 times 5, I want to multiply that together to give me 30. The second group, well, I've got 7, doesn't break down, and so I can multiply the 2 numbers on the outside. So negative 6 times 4 is negative 24 root 7. So now that's done, and that's done. I like to cross out what we have. The next term, we've got negative 2 times 5, and I just have root 7. So negative 2 times 5 is negative 10. The root 7 is going to stay. And the last term is probably going to be the hardest. We've got negative 2 times negative 4, which is positive 8. And then I've got root 7 times root 7. Now, some of you might know what this is, but I'm just going to rewrite it. So I've got those 2 roots together. So the last term, I have 2 numbers that are the same, so we can actually simplify that by bringing out that double. So 8 times that 7 that we're going to bring out is going to give us plus 56. So we've got 1, 2, 3, 4 terms. We want to combine like terms. So I've got 30 is a number and 56 is a number. 30 plus 56 is 86. We can add like terms. And then I've got a root 7 term and another root 7 term. They're being added and subtracted, so we want to add and subtract their coefficients since they have the same radical. So negative 24 minus 10 is negative 34 root 7. This term doesn't have a radical and this does, so I can't simplify anymore. Now, that was pretty challenging, so I definitely want to do another one because that's the first time you've seen that. And those will all be the longest problems. So let's look at example number 6. So I've got 2 terms in the first group and 2 terms in the second group. It doesn't matter how many radicals you have, so don't focus on that. So we're still going to double distribute. So I'm going to take this 2 root 6 and we multiply it by both of these terms. Now, some of you can skip a step, but I'm just going to write it all out. So 2 root 6 times, the first term is 5 in the second group, plus we've got 2 root 6 times the second one is 8 root 3, okay? So all of this is together and all of this is together. I've distributed the first term, so that 2 root 6 I don't have to look at anymore from the original problem. Then I'm going to take root 3 and do the same thing. Root 3 times the first term. So root 3 times 5. And then root 3 times 8 root 3. So root 3 times 8 root 3. So this is a term and this is a term. Terms are separated by pluses and minuses. And when you double distribute, you should have 4 expressions that you're considering. So let's go ahead and simplify this a little bit more. So the 6 breaks down into 2 times 3, which isn't a double. So that means 6 is going to stay as my radical. So 2 times 5 is 10, root 6. And that term's done. I've got, let's see, 6 is 2 times 3. Actually, I'll just rewrite it. So I've got the 8 times 2 on the outside, which is 16. And then I've got 6 times 3 on the inside. I'll wait to clean that up. Sorry. So this term's done. Then I have a root 3 and a 5. I can't do anything, but we always write the number outside first. So I'm going to switch the order and put the 5 first. So that's done. Some terms will be quicker than others. And then the last term, I've got an 8 on the outside, and I've got a 3 and a 3 inside. Okay? So I know this doesn't look like I made it any shorter, but we did. So we've got this, 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 and this. We still have 4 terms. So we need to simplify the radicals if we can. Well, 10 root 6 doesn't simplify, but I can't get rid of it yet, so we're going to leave it alone. 6 breaks up into 2 times 3. Here's a double 3, so we're going to multiply that 3 by 16. So I get 16 times 3 is 48, and we had a root 2 left. 5 root 3, that doesn't break down. And then the last number, well, I've got a double 3, so we can multiply that. 8 times 3 is 24. And I don't have anything left in a radical, so I don't have anything left on this answer. Now, I still have 4 terms, and we want to see if any of them can be combined. I've got root 6, root 2, root 3, no root. Since they all have different roots, we can't combine them. And this is our simplified answer. It doesn't look very simplified, but it is. So a lot of different scenarios can happen. It depends on what roots you're given, what terms you can simplify, things like that.